So let's talk about our AR example. How do you get started using the Tango AR? First thing you want to do is make sure you have your Tango Manager set up correctly. And to do that, you really need two things enabled. You need motion tracking for posing data. The pose data is what the Tango refers to as it's spatial awareness. So moving the Tango left and right and creating that viewport as well as moving in the space comes from enabling motion tracking. We have our video overlay, which is the video portion of it, and the GPU accelerated. That's experimental. Now, my recommendation would be to check out your project. Enable and disable settings like GPU and things that affect memory or visual effects, because that's where we find that the Tango is most temperamental. If something's going to break with the Project Tango, at least the AR example, is going to be with visuals. Either you're giving it too much or things are competing. So that's where you want to focus on if you have any issues. Next, we have our camera setup. So we have our camera and a plane, which is just, come up to here, game object, create 3D, and you create a plane right here. And that's what we have here. Rotate our plane. Make this negative 90 degrees. And what we're going to end up doing is for our plane, we actually need a material. And for this material, it's actually the AR example. So we can go ahead and just create a new material here. Go to create. And we want to go to material. And we can call it ARX, for example. Now, when it comes here to our shader, we want to make sure we have the Tango UYUV to RGB. And then we just grab our plane and we just click and drag and drop this on here. It'll automatically replace it. And now we have our shader. Now, along with our shader, remember, we're basically creating our AR screen. So we have the shader to convert the colors, spaces, and now we also need our AR script. So you can just click on Add Component, and we can just type in AR, and it goes to AR screen. Now, our AR screen is going to need two things. One is going to need to know what the material is. Second is going to need to know what the camera is. So we know what our material is, and it's our AR material, which is what we have here. Same thing that we have here. And the second thing we're going to need to know is where is our render camera. Our render camera is this camera, so we drop it there. Same settings here. And so that's how you create this plane that you see here. Very simple, not a lot to it. These are all instances that already exist in your scene, but if you need to, for whatever reason, jump in and create it, that's how you go about creating the plane. So let me explain what that relationship was. And so what you have here is you have your pose controller. Your pose controller is what gives you the data. That's what gives you the ability to get the real world motion into Unity. And so the pose controller is responsible for converting that data into something that Unity can understand. And our AR screen, which the pose controller then updates, is responsible for the actual view and actually gets the camera data. Now the thing about the YUV is that it actually is not just a color image. It actually contains both your color information, your luminosity, as well as U and V, which come out to coordinates. And so what you have is a more in-depth image than just your color image. And you can go on various sites and just Google YUV if you really need more detail on exactly how it works. But it's a common format that just happens to not work in Unity. So that has to be converted to RGB, which is just your raw color information. Because if you look at a YUV color space, it looks weird. It's like a rainbow with, just you see highlights and lowlights and things are mapped differently. And so our pose controller takes that information, takes our AR screen, and then it actually then both grabs the movement in physical space as well as the camera's perspective, an image, and then our AR screen script converts it. And so that's what you have a combination of the two working together to get the data, but our camera script is really our controller. So if I just click on this environment real quick and just explain this, what you have here is just a simple environment with a tiled grid here, which is just a white pipe, as well as a locator. This locator is 003, which is 3 meters forward, as well as on our 00 plane. This is important because when we actually run our AR example, we want to actually know where our 00 plane is. Very important when we talk about our camera, because remember, we have to convert information. So let's take a look at the script that makes up our Project Tango example. First off, you'll see that we're extending the model behavior class, as well as inheriting the iTango pose. The iTango pose is how you set up your actual pose controllers. So if you want to create your own, you want to make sure that these two are both extended and inherited. This public variable is how we access our AR screen, and this is how we get the actual script component. So if we open up Unity, you'll remember we had our camera, we have the pose controller, and we grabbed our screen and dropped it right onto our public variable. And that's what it does. It actually grabs, if I click on video overlay screen, it grabs a reference to this component right here, this AR screen script, which just allows us to run code from our from different components. If this is your first time ever seeing that, check out my YouTube channel, eAbelard, and you'll learn more about the basics of Unity and how it works, and the importance of using component versus other programming strategies. For the most part, what we're looking at here is just Tango setup information. This is just simple bootstrapping. Is a Tango available? Finding the Tango application. You don't need to do this step. Actually, this is probably one of the worst steps that you can do. We already know that we're working in here. I would recommend you actually going ahead, and if I'm going to open up Unity, all this does is look for this. And so in Unity, anytime you use find, get object, it's an overhead. And I'm going to be honest with you, the Project Tango eats up, and it's not as efficient as you would like it. It's a first generation, so anywhere we can leverage any optimization will go a long way. So we can actually get rid of that, and I'll show you that in a later video on how we actually change the script and modify it to work more efficiently with Unity. And so that's what this is. This just gets that object, and if it doesn't exist, and well, excuse me, this is not null. So if it does exist, then this happens. If it doesn't exist, then this happens. And so that's just, once again, just simple bootstrapping. Now I'm going to go down, before I cover the pose available, I actually want to go down to the bootstrapping. And this is on Tango application permissions event. And what this does is this is a responder to when you load up your application and it asks you a question, or you get that prompt that says, do you want to allow such and such event. This is what actually fires. And so what will happen is whether you click accept or deny, a boolean will be passed. In this case, we're referencing it as permission granted. You can change this name, it's totally fine. It just has to be a boolean that comes. And so what this says is, if permission is granted, run the following. And so what you're getting here is bootstrapping down to the Tango pose, and that just gets the data ready. Then what we have here is we're grabbing our initial positions. We're grabbing our initial frames and quaternion. When you look at position and quaternions, what you're looking at is really the current transformation as well as the current rotation, and that's what quaternions is how you actually convert your rotations, from quaternions. Then down here what we have is we have a matrix, and normally when matrix are much more efficient and faster to work with when you have position, scale, and rotation. And so you can actually do all the math and grab all that data from one place. Funny enough, you can actually do the same thing in CSS. That's how widespread matrix are. And so it's a 4x4 grid that holds the position, scale, as well as transformation or position, scale, and rotation. And so you throw them all into one matrix, and then you can modify them and then get those raw values. And it's a much faster and compact way of working. Some more advanced math, but you know what? It definitely goes a long way. And so that's what this is. This is, getting our initial values. Next, if we come back to our on Tango available, this is what happens every time the data is actually available. So you can think of this as an event that happens on like every whatever seconds or every milliseconds. So it's something that's constant, and it's more like a coroutine. That it's always being fired every time. Whether or not the data is usable is what we see here. So if pose is equal to null, this basically means that event fired, nothing is there. Return, don't run the rest of the code. And that's what this initial body from 143 to 47 does. Now this is the meat and potatoes. This is where everything happens. Now, as we saw previously, we have our position and our rotation. Now, something that I think is absolutely great programming strategy is just to make sure that the pose is valid. And so that's what this is. Just make sure our pose is valid before we, waste time going through all of this. And so what we have now is a repeat of what we had before. We grab our data, we run into a matrix again, and then we go ahead and we set the position and the rotation. Now, in a later video, I am going to completely get rid of this. And the reason for that is I've been developing games for quite some time, and there's nothing worse than explicitly setting values like position, rotation, x velocity, y velocity from one position. From one actual reference. There are many times where you'll need to re-reference that information, and because of this strategy, you can't. And so we'll look at something that we normally use in Unity, and it's actually using our input system and setting the horizontal and the actual vertical axes. Just a different approach, but it leverages or allows us to leverage so much more of Unity. And that includes if we need to create a UI, let's say we're going upstairs. If we want to be able to track that you go from one level to the next level, having our positions set like this won't allow us to do that. But having our vertical and a horizontal set will allow us to do that. And also, if you want to use Mechanim, it opens you up to using Unity more efficiently. And another great example is, so this quaternion, we have our look rotation script. Or when you have a look rotation, you basically are turning, and this is how the camera turns in the real world and to match what is happening in the virtual world. Well, if we wanted to add a little delay, just to smooth into a turn, we can't do that because there's a one-to-one relationship here. And so later video I'll show you how to separate that. That pretty much covers how the actual pose controller works. Next we have our AR screen. Our AR screen is responsible for two things, and it's rendering the image as well as making sure our width and height ratio remains correct. And that's what you're seeing here. So our screen width and height, which I think is the best way to do it. Qualcomm is working on the next iteration, which is supposed to be a phone versus a tablet. Now, let's say that's a 720. No, so the Project Tango tablet is a 720. According to the specs, version 2, which is the phone, is supposed to have a lot more power to it and hopefully more stability. And so that can very well be a 1080 versus a 720 screen. And so having an explicit way to check the screen width and height and make sure the ratio works is actually very efficient, because this code will work on both platforms. So it doesn't matter what form factor you're on. And so what we have here is our material. We're actually setting the texture to the texture that we're getting from our Tango API, and we're setting the different values, the Y, U, and V, and then the shader is responsible for actually displaying the data. We'll look at the shader in a little bit, and I'll show you where that actually happens. And so the rest is just regular Tango information. Something that's very important is this video provider. Register latest frame. That's how we get the actual latest frame. And so once again, it's just basic, Tango setups. This, however, set screen vertices. This is how our screen is resized. So vertices 0, 1, 2, 3, 4. Well, sorry, 0, 1, 2, 3. It's clockwise. 0 top left, and then it just goes right, down and then left. And that's how the screen, our AR screen, is resized. So if I jump it back into Unity, so you can see that this video screen, it's probably sized correctly. Yes, because of the scale. Because that's actually the ratio. But let's say we went ahead and we did this to the screen. Now you can see this is stretched, and so what will happen is if we take our image that's coming at 1280 by 720 and we map it to this, it's not going to say, wow, your UVs are correct, let me map this thing into a perfect, the perfect dimension. What will happen is it's going to stretch all the way across. And so what that script does, or that part of the script does, is that it actually sets these vertices to make sure that the ratio is always correct. Once again, another great feature, because it doesn't matter what form factor you're on. And so that's what this is, and that's what it sets up. So let's take a look at our shader. Now this is a really important one. So the way 3D works is you have materials, and materials are responsible for giving you certain settings. The shader is responsible for running those instructions and how the information gets displayed. And this is an important one, because in the beginning we didn't have a shader, or a good shader that can actually do the conversion. And so trying to use a Tango with just the image, trying to grab the image from the camera, ended up breaking things, and it was running at 2-3 frames per second. So this shader actually gives us the ability to grab the actual the image data and drop it right into our properties. And so if we go back to our AR screen, we have our material. So that's what we're seeing, and we're setting the texture. And this is how we're actually grabbing these properties and setting those various image textures from our Tango overlay, our video overlay, to our particular channels. And then just to sum this up, not to get too deep into shader logic. And so basically what we're doing is taking the texture and eventually converting it over to RGB, and just grabbing that data and then sending it back. And so that's pretty much what you're seeing here. Is just a conversion table. So now, will this actually work when we export it? It will. It will. I've actually tested this many times. So this is actually when the first iteration of this video was done. It was done with Prometheus, I think was the last one, and O came out. So I wanted to wait and actually test it out and make sure it worked before doing the video. So I didn't want to release a video when a new SDK was updated. Which, by the way, you didn't have to do a full upgrade. It was more of just the SDK and the core update. So you didn't get an over-the-air update. But you know what? An update's an update. I'll take it. And so we're just gonna go ahead and render it. Let's go on a limb and just say this will work. So I have this thing rendering, and while I'm rendering this, I just want to point out something, and it's that when we go over the project settings, it's very important that you test, test, and test. I know it takes a while, as you can see. I'm actually doing this in real time, so you can see that it takes a given amount of time to send over a very basic project. But what we've noticed in some examples and some prototypes that we did is we added lights, we added animation, we added textures. We started optimizing like we were working on a mobile device, and then out of nowhere it stopped working. And it was hard for us to figure out where we messed up, because just it didn't make any sense to us because it was working prior to, but the graphics ended up biting us. And so it's important you keep testing and making sure that you don't have too many things on the screen, or you're not changing too many graphical elements. So if we look at our device now, we have that prompt that we spoke about. So I'll just grab our C# right quick, go into our pose controller, and this is going, actually no, it's actually the bottom one. So remember we talked about this permission? Well, this is what we're looking at on this screen. So we have no thanks, and we have turn on motion tracking. And so we're just going to turn on motion tracking because we're excited this is actually going to work. And so you see, you get that nice pop action that just happened. And why did that happen? We're going to jump into Unity and explain that. But you can see, you can look at my screen here. We have our little locator here. Really cool. And not much to it, but it works. That's pretty much the essence of what we've been trying to accomplish. And so if we go into Unity right quick, our popping action happens because of our camera. Now this is partly why I said I don't like the idea of the one-to-one relationship, and it is because our one-to-one relationship ends up creating a like a position is always equal to X. And so what happens is it's not relative, and by relative and absolute I mean in the real world, if I'm in my bedroom and I get up, the camera doesn't jump into the living room. It doesn't really make any sense. Like you don't change perspectives like that. And so what's happening with, and that's what happens with absolute. With relative, what happens is if I now move, I'm going to be moving relative to my current position. So I'm getting out of a bedroom. I'm going into the living room, or I'm going into the dining room. That makes sense. The Tango currently doesn't do that. It does a one-to-one. And so what you get is right now, our camera is set up like this. We end up, once that initial bootstrap happens, you get this action. And that's why it pops. It's because it sets it first to 0, 0, which tells me that the first iteration of the Project Tango is actually null. So then we end up getting a 0, 0 reference. And then from there, the previous reference was 0, 0. And so the next reference is going to move based off of the previous reference. So it's 0, 0 to, wherever you move to next in the real world. And so our pop comes from that. We actually noticed that and so you'll see another project that we're working on. And in that project, we have a flying, I'll say a flying island. And we have our camera set like this. And we have 3 islands. You can kind of see, a little bit of graphical. We try to, to find little ways that we can push the Tango just a little bit to, to see how much environmental information we can add. So we have plants, we have, some grass, we have some trees blowing, we have wind effects. We have a few other visual effects on top of that, and we would really like you to start off your experience right here looking at this particular angle. But of course you get that popping action, and there's nothing better than trying to present and be like, wow, this is a really cool prototype, we got it this time. And then everyone's looking at it, and then you get this little, wow, that's so cool, pop. Immediately it's the start of your presentation, and everybody's just like, it's broken. And so that's what you get. You end up getting that little pop action. Uh, our example, I said actually works, is partly because these settings are an optimal set of settings. So I'm just going to run through the important ones and then go back and explain why. And so we have forward rendering for our rendering path. We have OpenGL, which you'll actually see two of them. You'll see 2 and 3. If you're using the newest Unity, you'll actually get this automatic graphics API. You'll get static and dynamic batching as well as GPU skinning. This information is just really build related. Most important, don't optimize. I know, just don't optimize. And so let's go over, what really makes a Tango tick. And so with this AR example, we have our rendering path. So rendering path, think of it as how lights are interpreted. Forward is the more basic, right? You get the minimal amount of lights that are interpreted. So if you have 20 lights in the scene, they're not all going to be rendered. They're not all going to be calculated. Deferred will do just that. Works on different paths, and it'll actually look at all those lights, and it'll composite more lights. I won't say unlimited. That's a really bad word to use in computer graphics, but you do get a decent amount of lights that will be rendered, and it's per vertex. I'm babbling. But just know that forward light is the basic. Deferred light does allow you to do more lighting, but also, if we look at this, you have vertices, all these at points where these lines meet are vertices. If you're new to, to graphics or computer graphics and 3D in general, that's what that is. And so deferred lighting basically will light and take account both all your lights as well as vertices. And so it's a little more intense. And so not a lot of mobile systems can handle that. In previous incarnations of our SDK, forward rendering path would not work, but deferred would work. And like I said, for those devices that aren't able to handle deferred, forward gets set anyways. Dangerous. I clicked on automatic for a reason, because this is how it comes by default. Don't let Unity choose which version of OpenGL to use. You notice that we didn't have OpenGL 3. I actually deleted it because it will break if you use OpenGL 3. So use OpenGL 2. Will this change? Hopefully. Why? It's always better to go with the latest revision, right? You get 2, you're like, wow, it's an older version, let's use 3. But the truth is that, once again, if you don't need something, you shouldn't set the setting, right? Multi-thread rendering. I love multi-thread rendering because it breaks every time we use it. If I set multi-thread rendering and I, set a build, and this happens, and this is really based on your project. Once again, you have to remember that the Tango is not the most efficient, device out there. And I say this, not to be critical of the device and the team, but to make sure that you're aware of the device that you're working with, and so that you understand that there are limitations. So you have to be extra mindful. It's not just about setting up and, going on and saying, hey, it's an Android device, I can optimize like an Android device. You have to be a little more sensitive to the amount of graphics that you use and the type of settings that you have. And so this runs, and you know what? I'm not even recording it. let me just quickly record it. And so this is what we get. You get this nice blue screen, right? Awesome. And so this is what happens. You start changing too many settings, and let's face it. This is a problem, and we've had quite a few sessions where we're trying to figure out why this thing is broken, and it's because of that. It's that one setting change. And this is why I can't stress enough. You need to test every single setting when you make changes. Don't just arbitrarily make changes. Multi-threaded rendering, which you would think, once again, is something that would be beneficial, actually breaks this. Something else that's very temperamental is our static batching as well as our dynamic batching. both are extremely temperamental. And so what you're looking at is touch the graphics at your own risk. And static batching is very helpful. Dynamic batching is very helpful. But if your scene requires those, test it out. If it breaks, you might want to look for a new way to optimize your meshes and see if there's other places you can optimize your scene in general, because it's painful when this thing breaks and you don't know why. So be very mindful of not having multi-threaded rendering, and be very mindful of having static and dynamic. Sometimes it works. We've had projects, prototypes that we worked on where it completely worked, but this example that I'm talking about, where we have our flying city or flying sky island, it definitely broke, because we're using a lot more. You had the wind effects, you had the trees, and we're using speed tree, which is a hog anyways. Just you start adding all that together. You gotta, there should be a performance metric, that your team sets up. How much can we allocate to what? And speed tree is very intense on mobile devices, and so GPU skinning, all that, all these things affect it. So where you can leverage one, you can kind of get rid of another. Identification has nothing to do with the actual Tango. It's just an Android configuration. These are totally fine. TV compatible. Once again, Android settings that aren't very useful at this moment. Keep everything external. Don't use internal, because just if you can jump on SD card, you're better off, writing or being able to write to an SD card than just writing to internal, because sometimes people don't have as much space on the internal. The optimization. Don't optimize. Just don't do it. Just don't do it to yourself. If you start optimizing, so typically when you release, you want to use a subset of .NET 2.0. And you want to use micro, right? And that's the best way to optimize. However, if you do this, once again, it will break. It will totally break on you, because then Unity is going to start stripping out pieces that Tango's using but hasn't registered that it's using. And so what will happen is Unity doesn't know to keep those particular items. And so by not optimizing, you end up, well, not optimizing, but you still get a working example. And so that covers everything you need to know. We talked about the scene, we talked about the scripts, and then we talked about the build. Now, this is just one example of, just the large scale, process of working in the Project Tango, and specifically the AR. But we're going to do more, and the way this is going to work is we're going to do the next example, which I haven't decided which one. I haven't been told which one to do next. But we're going to go and do another example, and then afterwards we're going to come back and do another video on some more application of this AR experience, just because it's a lot, it's a lot. So I want to break it down into smaller chunks, because I believe this video is going to come in at like under an hour. This is one example. So I didn't want to add, a 2-hour workshop for, just an introduction to how everything works. I hope you enjoyed this video. I know it was a long one again. There's no way to cut it. It's just, there's a lot of information that needs to be covered. However, you should be able to jump right into the AR example and know exactly where things are. And that's what our goal was, and our goal is still to make sure that Project Tango has the best type of documentation. That's what we're doing. We're documenting. So this is Edison Abelard. You know the deal. You can find us at passion47.com. Check out our blog section. We're going to keep talking about Tango, and we've already submitted our Unity talk, so hopefully they'll allow us to do a little bit demonstration and talk about some really fun stuff that we've been working on with the Tango. And if they don't select us, it's alright. We'll still be at Unite Boston, and we're just going to release all this material anyway, so you're still going to get it. It's not going to be hidden. But enjoy. Here's an Avalon. I'm out.